All right. Hello, everyone. So my name is Kevin Jones. I'm here to talk to you today about pushing infrastructure to the edge on hyperconverged cloudlets. So I work for the US Public Sector Division of Red Hat, and we actually set out to solve a problem that we had. When we were sending solution architects on site to demonstrate our capabilities, we typically don't get network access, and because of that, it makes it really difficult to show software. So what we decided is if we needed a couple things to solve. We needed a cloud that could run all of our capabilities, so that includes OpenStack, Ceph, maybe Rev, maybe OpenShift. Tie all that stuff together and bring that into a conference room, plug it into a regular outlet in the wall, broadcast our own network, and then our customers can get access to all our software. So it also had to be carryable by a solution architect, fit on a plane, and have the full capabilities. So that's what's in this case right here. And the first one we built, it actually looked like a bomb. We prototyped it out, and it literally, the only thing it's missing is the LED timer counting down. But this one is much prettier and has a Red Hat logo, so maybe after the session if you want to come up and look at it. The way this is going to go today is I'm going to pull this out, plug it into the network here, and I'm actually going to kick off a video for y'all to watch while I'm doing this. And I'll power it up, and we'll see it actually running at the end of the show. So this is a video talking about Hurricane Harvey, and I'll explain why I'm showing this video in a little bit when I talk more about use cases. Let's see if I can get sound.
You hit the video.
Yeah, okay. Yep. Yep.
Gonna head out to Austin. I'm not sticking around here. My first real hurricane. I'm scared.
I hope we're not overreacting, but and I hope we are overreacting after all. Nothing catastrophic happened. Hopefully.
What concerns me the most right now is whether or not people have heeded the warning that they have not. Their window to evacuate is rapidly coming to a close.
It's either go or die.
It's a serious storm. It's going to last 4 or 5 days, and quite frankly, this is day one. And let me tell you, it is dropping a lot of water.
You're in the eye now. It's calm and eerie. Let's look at the back wall of this hotel, and the staircase is gone. On the 3rd and 4th floor.
That swept through this area. Oh my goodness, something just fell. The side of that home, the bricks just fell from the side of that home.
Harvey's wind speeds are now down to 75 miles per hour, but we're now entering what I call phase 2 of Harvey, potentially catastrophic flooding rains.
Feeder roads all along here flooded. You can't get out on those.
Right now where we are, the water is rising very quickly. It is not a good feeling when you are driving down the freeway and there are headlights coming at you.
We had to actually climb to the attic to the house, but I had my tools, and if it keep rising, I was gonna bust the roof open.
Floors are gone, sheetrock is gone, and cars are gone. So thank God.
You've got 2 trash bags. Yeah, this is it. Sorry.
He says he's got 5, 6, 7 people. It's gonna be a little bit, but we'll come back.
We don't have anything. We lost everything in our apartment. It's just really unfortunate.
There is a reality that we have to come to grips with, and that is we are just beginning the process of responding to the storm.
The boats are nice. They're the best, right?
Yes, this is the rescue team.
This is the rescue team.
I didn't even imagine that it was going to be this catastrophic like this. This is horrible. I have my 2-year-old. He told me he was scared.
It was just a blessing to be rescued.
Please bless every one of their souls, Lord, in Jesus' name. Amen.
Amen.
We can get to places a lot of people can. As far as yesterday went, we were able to
we're very, very happy to be able to say we were able to medevac several people that wouldn't have otherwise been able to be medevaced.
We're just extremely strong. We're going to get through it. You know, we're all going to come together and make sure that this community comes back.
There was a lot of people to rescue out here. So I went Facebook Live, I got on my video on there, and help was coming in boats, and had already started already once we got there, and we were able to get people out.
It's always been the same. I mean, Texans are just a strong bunch that we'll just rebuild and put it behind them.
He's my neighbor. He has a big truck, and he wants to help his neighbors. Life doesn't get better than that.
No.
You look beautiful.
No, I would have worn my wig for the occasion.
There's a lot of good people down here at Bento. I mean, I feel right at home down here. I miss my family, but I feel right at home.
You know what? This weekend, we're going to be pretty normal in Houston, because that's just the way we are.
Texas pride. Texas
pride. You're going to see it this weekend.
All right, so I'll get back to why I showed that video in a second. I wanted to show you some of what it would be like to be a first responder or an agency going into a situation like that. So what I'm here to talk about today is the term Cloudlet. So a Cloudlet is a mobile, enhanced, scalable data center, small scale data center that's pushed out to the edge of the internet. In the case of a situation like Hurricane Harvey, it might actually be beyond the internet. There's no network there. When they show up, maybe the cell towers are gone or are not usable. This one in the picture is the one that's actually up on stage. You can come see it. So this is the one we've worked with Intel and a company named Tranquil PC to solve our problem. And what has happened is as we've taken this around and taken it to events and to our customers, we've started to get a bunch of use cases coming in. But when you talk about what the different requirements are, out of all the use cases, some commonalities come up. So one of those is portability and a small footprint. One of those is ruggedization. Those two are usually uniquely needed for the use case. So the use case will determine that it needs ruggedization and they'll sacrifice on portability, or they'll need portability and they'll sacrifice on ruggedization. But common among all of them is the need for running on low power and having the same bits on the kits that's in the data center. The other things that we've heard that are cool ideas is this box here is mostly focused around compute and has about 5 terabytes of usable storage on it, but having a cube that you could stack with this that is very storage dense. And then the second piece is doing data analytics at the edge with GPUs, so putting GPUs in the box. If anybody remembers from the Boston Summit, Beth Cohen got up on stage and showed a cool little box running OpenStack for the edge of the telco use case called Edgy. And she said, we need to be in the edge, we need to be in the data center, we need to be all over the place. That's a great quote, right? And there's a lot of talk in edge about telco and NFV and all that. But what I've come here to talk about specifically is the things that we've discovered beyond telco for edge. So rolling this thing around has brought many, many use cases to us in US public sector particularly, but they apply differently across the globe, actually. What I do want to give a small caveat, so I'm going to talk in generality about these use cases. They don't necessarily equate to a Red Hat customer, but all of the concepts have been discussed with us from the customer base. So the first one goes back to the video I showed. So in the US, there's an agency called FEMA that is in charge of response to disasters, but there's agencies like that all over the world. And then there's charitable organizations like American Red Cross and all of those that also have to respond. And so if you can imagine from the sense of that video, what it's like being called in to be a first responder or to go into that scene and not knowing what the network situation is, not knowing what the power situation is, you have to bring all of that with you. And the idea is that when you get there, you're running the same applications that everybody's been tested on, trained on. All of your logistics and communications, they have to come up and run exactly the same way that they would when you were working on them in the data center. So they will literally send trucks out with their infrastructure, stand up their own networking, and put all the applications up in place. So this is a definite use case, right? Hurricanes, floods, the nuclear disaster in Fukushima, like responding to these events is very crazy. And we're at an IT conference, we think about DR in the data center, but this is DR for real life. You're responsible for actions during the event and also recovery after. Katrina, FEMA was there for over 2 years after Katrina in trailers. The next one I want to talk about is one that has existed for quite a while, which is military operations. So this is both like remote operations like you see in a tent here in the middle of a desert. And these are very common looking kits right here for the ones that are this day and age. They're very, very expensive. This is one of the use cases that focus on ruggedization. So they have a mil spec that determines like how much sand infiltration you can have in the kit, how much extreme temperatures it can withstand, heat and cold, etc. But these kits are very, very expensive as they are today. They have to survive transport into hostile environments. They are very, very harsh places they have to go into. The places they may be is indeterminate. It could be in the back of a Humvee, it could be in the belly of a submarine, it could be on a ship, it could be in an unmanned aircraft flying over the location as well. The most crazy story I've heard is the idea of actually taking a kit, more rugged than the one I have here, pushing it out the back of an airplane, parachute deploys, and when it deploys, it kicks off the deployment. It's got battery power in the kit. By the time it lands, it's most of the way through its deployment. It can run on battery power 4 to 6 hours, and when the operator arrives, the software is ready to go. That's like, I didn't even know what to say to that guy when he was talking about that. So that's a very, very critical one. This one I want to talk about is actually Red Hat has this problem. So we send instructors out, and the way we do this today is 1 to 4 Pelican cases full of laptops that are under-resourced the day we buy them. And the more and more software we build and the more resources it consumes, the harder and harder that becomes. Our instructors, they arrive 2 days early so that they can deal with making sure all the hardware is in check, making sure that they can re-image all the systems and get them in a good shape for the students coming in. They have to set up a full LAN network inside of the classroom, and it's a real pain. The other situations here for our certification classes, you can't have network connectivity. So everything has to be in the environment ready for the student to go. OpenStack happens to handle this situation very well. It's multi-tenant by default, has network isolation. We can segregate the students and give them the resources they need. So it would be much nicer if the instructor could just carry his cloud with him, take it into the classroom, maybe even the morning of, kick off an Ansible playbook that provisions the student environments. When they walk in, they bring their own device, tap into the network, and they got their student environment to work from. Again, low power, we'll choose portability over ruggedization. It needs to be able to take a couple bumps. That's what this one can do. But you're not going to put this one in the middle of the desert and expect it to run. Right? So there's this concept of sort of semi-rugged, but more portable. The next one is one that I got a chance to work on recently, and it's very, very critical. I actually didn't really understand the magnitude of it until we started working on it. The federal government last year had 67,000 breaches of data. So when you think about how we're having to battle that, that's just the US federal government. So across the globe, this is critically important that we give the operators that are defending this the tools they need to be successful. And so what they do is they developed the cybersecurity tools on a common platform. They need to be agile, be able to move quick. They then need to move those tools, ship them out to another location where they're tested, validated. They then ship them to another location where they are used to train the operators, the field operators. And then the operators themselves get kits, similar to the ones you see in the pictures here, shipped out to location wherever the compromised network may be. They have network interfaces that they have exposed so they can actually hook into the compromised network and start sniffing packets. And it would be way better if the operator had the same platform that all the tools were developed on, tested on, that they were trained on, and when they get to the place that they need to actually do work, they know their tools are going to do what they need them to do. So this one is very, very critical for US global security as a whole. The next one is very near and dear to my heart, both literally with my shirt on today and also because I came from NASA Langley Research Center before I was at Red Hat. And I was working with the likes of NASA JPL and some of the others on how we could build platforms that would allow us to go further in space as well. And I continue to work with space agencies in my current role as well. But the idea is that we need to be able to ship Earth technologies like x86 commodity hardware, open source software, and put those into a place where there is zero gravity, extreme temperatures, small space to work in, and we need to know that they're going to keep a robot roaming around on Mars or a person alive on a space station or on Mars habitat. So we would actually, the way that they're planning this now is actually to ship capability to stand up infrastructure on Mars first, build its own habitat, and then when we send people to Mars, it will be ready for their arrival so that they can stay alive. So I'm really excited about the work that's being done there. Now, like I said, I couldn't really talk in detail about any specific customer use cases in there, but I wanted to talk about one I could actually go into detail in. And this is a project I started working on a few weeks ago internally at Red Hat. And I was sitting there working on this with my peers and hadn't really started this presentation yet. And it dawned on me that I was working on a use case for the presentation I was about to do here. So this is a representation of the mobile portfolio center that Red Hat is about to send around the continental US and also parts of Canada. It's a mobile classroom, a mobile demonstration lab, and in the trailer you can actually fit 40 students in there. This is a picture of the MPC builder crew. Some of them are not there. They are in the room here. So it's Ken Holden there, Laurent Dome, myself, and then Joe Ankoviak is there. And one that is also hidden is Christian Hernandez. We had a staffing, we had a project owner, and we had a project manager that kind of kept everybody in check logistically, and then we had one architect wrangler to keep these 5 solution architects in check. And we got 3 of these kits, put those on that truck. The first event will be May 30th, and the truck is going to run 3 of these as its data centers, use it for the 40 students that can be accommodated in the trailer. It needs WAN connectivity when there is cell signal available. Joe had to build out our network for that. You need Wi-Fi on the truck so customers can connect or students can connect their devices to it. And then we also had to think about how the solution architects that were in the localities who may not have the skill set of the guys in this project could recover the infrastructure, the clouds themselves. So we had to make it a push-to-button deployment. And the way we accomplish this is actually there's a build node in this cloud, an Intel NUC. It has a 1 gig NIC off the back. We can plug that into a Pixie network. It boots the NUC, lays down RHEL 7 on it, and puts the network in. And then from there, Ansible deploys the entire rest of the cloud plus the applications on top of it. So we had to think about how they would be able to be successful with this. This is an actual image of the truck. I thought it was pretty cool to see that. I actually suggested that they pick 3 of us and get us to get CDL licenses and then send us around the country and make a reality show out of it, like 3 nerds in a truck. They didn't go for it. This is us building it. That's our wrangler there, Sean Spurrier. Sean Spurrier is trying to tell us to stop outthinking ourselves. And we spent a couple days in a conference room in Las Vegas, North Las Vegas, building out these clouds. Pretty cool. One of the clouds is our RHHI, so it's Rev and Gluster. And there, the other 2 clouds are mirrors, and they are RHHI for cloud, which is OpenStack and Ceph as the infrastructure, and that's what's on the kit on stage today. From an architecture standpoint in one of the clouds, this is for the OpenStack clouds. We have 4 nodes in there. They're ASRock motherboards. They're mini ITX. They have Intel Xeon D processors, 16 cores on each one. They have 128 gigs of RAM each. They have 4 SSDs and 1 NVMe each. So from an OpenStack standpoint, there are 3 of them that are basically all-in-one OpenStack nodes. They're controllers, they're computes, they're also Ceph storage. And then there's one that is a monitoring node, compute, and storage. The layout is very similar to how we would deploy in the data center. So we do network isolation. There's a 10 gig Netgear switch in the box that can do VLAN isolation for us. And we split this out. I won't go into deep detail about those, but this is a common network layout for Red Hat OpenStack platform. From the physical side, the NUC itself has all 1 gig networking. The one at the top is the one I said is exposed out the back that we can put in a Pixie network. The other 2 we bond in LACP to do all the other networking that node needs to do. And then the 4 nodes themselves have one 1 gig NIC, which we use for shared IPMI and provisioning. And then the other two, we bond LACP for all of the other cluster traffic and workload traffic. The storage layout is Ceph on there. So I use one of the SSDs for the operating system, and then I take one of the NVMEs and I use those for Ceph journaling, and then the other 3 SSDs come into play for the Ceph OSDs. So in this kit on stage, we have about 5 terabytes of usable Ceph storage. In the kits that are on the truck, we doubled the disk size, and it was 10 terabytes in the box, usable. The concept here is that we lay down the infrastructure on the box itself. It can run in total isolation. It can manage itself. You can run workloads on top of there. One of the most recent ones I've been working on is pushing these things out to build distributed simulation capability. And so you take a simulation that can run in isolation on the box, and then when it has connectivity back to the central data center, it pushes the data that needs to be sent back there. And that's sort of what you see represented here. So if we wanted to tie this into an uplink network and plumb it into a public cloud, we could do that. We in this box would use CloudForms to interact with those other cloud providers. So it could be an OpenStack cloud back in the central data center. It could be AWS, Azure, Google Cloud Compute. But the idea is that the box is isolated, can run everything it needs, and then the connectivity out is configured when you do need that. This is actually an example kit. So Red Hat is obviously not a hardware company. So I can't literally sell that box right there. That's made by a company named Tranquil PC. And what happens ultimately is when I show up, I get this, man, I've been trying to build that for the last 2 years. And they say, can I buy the box? And I'm like, well, you can call Tranquil PC to get the box. For US public sector, that's actually a problem because they're a UK company and they don't have guaranteed supply chain. So we started working with DLT to see if DLT could build me a very similar capability. They are 2 components away from having ITAR compliance, and that's the drive sleds and the power supply. So we're working on being able to actually have an ITAR capable kit there, certified kit there. And this thing, I love this name, they call it Ice Cube. So it's an integrated cloud environment. And the idea here is you buy a single SKU from DLT, they assemble the box, lay down the software with automation, and drop ship it to whatever location you want to. That's kind of where we're going so that we can actually answer the question, can I buy the box? Yes, you can buy the box. This is a semi-rugged kit. We are also working with them so that they can handle the ruggedized version. That will most likely be through another partner, maybe a Tracewell or a Klaus or somebody that's already in that space. So what I want to do now is actually switch over and see if we can actually just see the kit. So while we were, I'll show you this real quick. I won't make you read it. While I was spinning it up, you were watching the video. I kicked off an Ansible playbook once the NUC came online, and it went through and it started all of the physical hosts, and then it went through and started all of the workloads on top. So let's see if I can find my mouse. And I have to, give me just a second. All right, so what I'm going to do is I'm going to bring this other browser over to the window you all see that I'm not seeing. And what we'll do is we'll just start pulling things up. So the first thing we lay down is IDM, Red Hat Identity Manager. This is actually a part of RHEL. When you buy RHEL, IDM's in there. We use IDM in the box for 2 things specifically in this kit, local DNS and LDAP. You could also use it for certificate management. So if you wanted to lay down certificates, have an official CA in the box, IDM could handle that for us. The next one I'm going to show you is OpenStack. CloudForms. CloudForms self-service. OpenShift. Ansible Tower, Red Hat Satellite, and the last one, just because I could do it, is Rev running on OpenStack, which doesn't make a whole lot of sense, but I wanted to be able to show Rev when people talked about it. So it's actually running nested virt Rev on top of OpenStack. Now you can see I didn't provision I have all self-signed certs. One thing I'd like to show you is in the self-service, So the beauty of tying all this stuff together is that I can actually orchestrate application workloads on top of there. I can expose these out to the operators through a self-service catalog in CloudForms, and I can let Ansible Tower take care of all the actual provisioning, and I let OpenStack do the work underneath the covers. So we're gonna actually order a Spark cluster, which will go into Sahara. I'm going to pick the key name I want to use, and I'm going to call it Edge. And I'm going to order this just like I would order a nice fancy watch on Amazon. And while that's happening, so that's actually Sahara, so I have Sahara running in my OpenStack cluster. And so it's going to use heat to go tell Sahara to give me a Spark cluster. That's already defined in OpenStack. I'm going to log into OpenShift now. I'm already there. Just got to set my cert. And I'm going to show you an application that we have that I really love. There is a project we're working on called radanalytics.io. It is not a Red Hat product. It is an open source project that's out there. But what it gives the capability to, it's a baseline for doing Spark in containers. So the Sahara cluster on here, the Sahara is going to spin up a couple VMs. It's going to configure them as a Spark cluster. Oshinko is going to do that same thing for us, but it's going to deploy it in containers on OpenShift. So conceptually, the Sahara cluster is going to take about 3 to 4 minutes, give or take, from launch to configuration. The Edge cluster and container is going to take as long as it takes to start up the containers. But what I wanted to show today on this kit is that I could walk up here, pull my cloud, as if I were an operator, one of the cyber operators I talked about, one of the FEMA responders agents. I could pull this kit on, plug it in. It has its own networking capability here. I don't need the uplink. Oh, my Spark cluster is running, by the way. And just the fact that I can walk in here in this room in less than, what are we at, 30 minutes, 33 minutes, something like that. And I have all my infrastructure needed. It's all on the kit. It's all here with me. I carried it on the plane. I actually walked up to the customs agent with my cloud in hand. And she said, "What the crap is that?" And I said, "It's cloud in a box." And she said, "Is it all going back with you?" I said, "Yeah." And she said, "Great, go on." So, anyway, so that's kind of what I had for you today. Are there any questions? Anybody want to go into discussion about use cases you have or things that I haven't spoken on today?
So you have local repositories on the NUC?
So yeah, so what I really want to do, so we actually did that when we were doing it on the truck. We did a Pixie server, and we actually had a Synology on the truck as well, and we populated the Synology as a repo server, so it would pull content from there. What I want to do ultimately for this and for my customers is I have a USB stick that's populated and uses a Kickstart file to build the NUC. Then it mounts its content from there, puts it on the NUC, and then the NUC shares it. It gets more complicated when you have to think about OpenShift particularly. So when you're designing applications for OpenShift, if anybody's ever done a disconnected OpenShift installation with containerization, you have to have all the container images you want to touch. Any external resources that you're pointing to have to be brought local. And when you're building your applications, you have to think about that as well. So you have to deploy OpenShift with that in mind, and you also have to think about your application infrastructure. So all local resources have to be in the box or in the truck. So in the truck, we stood up a local registry, and we pumped in all the images we were going to need for the deployments. Yes? Yeah, if you do have questions, the mics are there so everybody can hear.
So first, thank you. That mobile transport, I work for Red Hat.
Okay.
The mobile transport unit will actually be at one of my customers in 2 weeks.
Awesome, man.
So thank you.
That's awesome.
Ken and Kevin and Laurent, who's not here, but I'll tell him. But my question really was, I don't know if you heard about the project at Crano.
I did, yep.
And the hardware profiles that go along with it, and sort of the standardized bombs that they're developing, or the frameworks, I should say. So this fits very nicely with some of those designs. 90 minutes ago, or maybe 2 hours ago at most, there was a talk where they were talking about the practical use case. So another disclaimer: I represent Telco.
Yep.
And one of the use cases was for the autonomous vehicles. So the question I had was, or first, I think I'll just describe the use case, which is the ability for these little devices. So they call them the roadside units, and then the onboard units. The description for each being the roadside units are the units that you'd place, obviously, on the roadside, with a certain distance between each of them, and the onboard units being the devices in the cars or the vehicles themselves. Because the vehicles are in motion, one of the things that's a requirement is URLL, which is the ultra resiliency and low latency for communication. Because it's one thing to make a call, but it's yet another when you have autonomous vehicles communicating with each other, and you really need that low latency. And the communication being between the vehicles themselves, but then also across the mesh, across the roadside units, so that if there's, for example, a hazard or a traffic hazard ahead, then the vehicles can inform the roadside units, which can then communicate with each other and alert the vehicles. So based on all of that, have you seen any similar use cases or the ability to equip one of these boxes with like a little radio such that it can be used in that way? From a DoD perspective, they would also have a similar use case from the idea of having unmanned aircraft flying with devices on them, communicating back to things on the ground or spun out. I know that some of the partners that are building these kits, they are building things of that nature. Like I saw one come in today from when they sent out the keynote I did yesterday internally. I saw one come in from a company named Blackbox, who is working on a kit that has capability like that has radios built into it, communication kit. So yes, I think that's out there. I think DoD absolutely has that use case, and probably there could be some sharing between Telco and the military initiatives to make that work well. But I think it's out there and being worked on, yeah. Okay, thanks.
Anybody else got any questions?
How is the NUC setting up the network on the nodes? Are they just DHCP and then it knows what IP addresses they're going to get for the config of the cloud?
So the way it works is the NUC itself gets a network laid down by the kickstart file on itself, and then it spins up 2 VMs on there, and the VMs get attached to bridges, right? And then from there, we use our installer, which is OpenStack Director, or in the community, OOO. So one of the VMs running on the NUC is communicating to the physical host over IPMI. So it powers them on. When they come up, they DHCP to that VM, and they get an address. And then from there, our director deployment, which is all defined in templates, so infrastructure as code, specifies how the rest of the networking gets laid down on the hosts themselves.
Thank you.
Yep. Anybody else?
Are any of the switches configured dynamically as part of the provisioning process?
Yeah, so the first step would actually be to lay down the switch config. Now in these kits, to get a form factor this small for the price range we wanted to, we have a Netgear switch in here that is web managed only. It does have a Telnet client, but the Telnet client is for like firmware backup and restore. And so there is no SSH daemon on here. If there were an SSH daemon and it were a fully managed switch, you would absolutely put the automation on the switch as well, so that the entire kit is push button deploy. The intention is that the DLT box that I showed will have a fully managed switch, and it will get laid down. I'm also working with our services team on a deployment that's going to happen on June 4th. That is going to include that as well. So that is more like a quarter rack size, kind of similar to the builds you saw in the pictures where it's a bigger kit, freight shippable, and that has a fully managed, data center switch in it. Yep. We good? All right, last call. All right, cool. Thank you.